The function f of x is represented by the equation f of x equals 3 times x squared plus 2. The values for the quadratic function h of x are shown in the table. All right, so we're given an equation and we're given a table, and we have to compare the two. We have to see which statement is true. So we've got the y-intercept of f of x is 4 above h of x. The y-intercept is 6 above h of x. The y-intercept is 8 above. The y-intercept is 12 above. So we can see that in each statement, we're comparing the y-intercepts. All right, so remember, you can always find the y-intercept by substituting 0 in for x and solving for y, because 0 for your x is going to put you on the y-axis, and your y-intercept is always going to be a point on the y-axis. So if we substitute 0 in for x, 0 squared is 0, 0 plus 2 is 2, and 2 times 3 is 6. So we can say f of 0 equals 6. All right, if you look at h of x, it already gives you a point for your y-intercept. So it gives you h of 0 equals negative 6. So you can see that is a difference of 12 units. So if we look down through the choices again, f of x is 4 above h of x. That's not true. F of x is 6 above h of x. That's not true. F of x is 8 above. That is not true either. And f of x is 12 units above the y-intercept of h of x. So that would be the correct answer. Now, real quickly, if you forget that you can just simply substitute 0 in to find the y-intercept, you also could graph it. So if you go to y equals and you graph the equation, 3 times x squared plus 2, and then you hit graph, you can see that 1, 2, 3, 4, 5, 6, that has a y-intercept of 6. So 0, 6 is going to be on the graph as well. And you also could do second table and see that point there. When x is 0, y is 6. So there's a couple different ways to find the y-intercept here. You also could graph those points if you wanted to see how far it is from this point to this point. But if you look at the graph and you know you've got a point at 6 and you have another point at negative 6, you can count. There are 12 units between 6 and negative 6.